Hello guys, today we are here to solve a question from the chapter integral functions, and let us read the question. What do we have? We have to integrate a function that is 3x upon 1 plus 2x raised to the power 4. So I can see that this is a pretty easy question, as we just have to eliminate this 3x part or this x part somehow. So what we can do? What we can do is that we can assume root of 2x square as t, and then we differentiate it with respect to x on the both sides. We get 2 root 2 x dx is equal to dt. Solving this, we get the value of x dx as dt divided by 2 root 2, and then we can substitute x dx here, x dx, as this is x dx and integration, so we can substitute it here. So what do we get? We get 3 by 2 root 2 and integration of dt upon 1 plus t square. Now we already know that differentiation of tan inverse x with respect to x is 1 upon 1 plus x square. So the integration is just vice versa. So the integration of 1 plus 1 plus x 1 upon 1 plus x square is tan inverse x. So we get tan inverse t plus c, where c is an arbitrary constant. But before signing off with the final answer, we need to remember that our answer is still in the variable t, but we were given with the variable x. So we have to back substitute the value of t into x. So we assume t as root 2x square. So we get the final answer as 3 by 2 root 2 tan inverse 2 root 2 x square plus c. So that is it. I hope you all got it. Thank you. Have a nice day.